Hi.
Hello, everybody.
So you're probably wondering, why are we qualified to talk about this?
It's amazing, this giant slide. It's so cool. Okay, so I'm Evan. I work at a company called Segment, which is a platform for helping you manage data infrastructure and customer data. And I'm a security engineering lead there.
And I'm Maya. I'm a product manager at Google. I work on container runtime security, but previously worked on encryption. So I care a lot about secrets. Quick disclaimer, nothing that I say is an endorsement of any particular solution.
It's important.
So what is a secret? What are we talking about? Well, the secret can be a lot of things. It's anything that an application needs at build or runtime. Some common examples are credentials, API keys, username, password combos. A really popular secret type is like your Stripe API key. It gets access to your payment system and is pretty critical if you were to lose it or if an attacker got access to it. Something that's not a secret, your entire application code, all of your config file. There might be parts of it that are secret, but probably the whole thing is not a secret. So today we're going to talk about how to do secrets management and why there's really no excuses at this point in time to do a good job of it.
Yeah, I also think it's kind of important to note that I feel like secrets management was a big thing that blasted onto the scene in like 2015, 2016. And there was a bunch of talks back then. And like doing hallway con out here 30 minutes ago, people are still coming up to me saying, oh yeah, we're still working on that. Like we still need a solution for that.
They didn't read your article?
They didn't read the article. And so I think we have between the two of us, we've kicked the tires on a ton of different secrets management solutions. And I think we have a pretty good idea about what works and what you should be looking for when you actually go and solve this at your company.
Cool. So there's a quote here, which is, secrets are the very root of cool. So obviously we're working on cool things.
Yeah, super cool. So I like to think about secrets in the context of my company Segment, which we are all on AWS. We use a ton of different SaaS providers. And I think just to talk about why management of secrets is so important, like we have AWS keys and we have Stripe keys, and I think everybody knows that those are really important, but we also have like hundreds of different SaaS tools that we use.
How many secrets do you guys have?
We have actually in the thousands. So if you look at it, it's I have a list here: HR software, payroll software, blogging software, community site, Okta, Salesforce, Slack, Zendesk, Optimizely, GitHub, and that's like just barely scratching the surface. So it is a big problem. And so I also really think that all of those secrets are supposed to be treated really sensitively. There's no such thing as like, this is super high value versus this is super low value, because you really want to enforce a positive behavior pattern with engineers that like they don't have to distinguish between important and unimportant secrets. And I think like these are examples of companies that maybe this is too large of a slide for you guys to see, but it's an example of companies that have made mistakes with their secrets management, like Trustico a few months ago. It's like the private keys shouldn't be accessible by the CEO, even though they shouldn't have private keys in the first place. There's like, you shouldn't be storing AWS keys in a public S3 bucket. I think we all know that one. I think the examples are there. There's like a large bucket of examples to choose from.
So how are people thinking about secrets today? You'll see this wonderful line graph that we've made of different options. And the line graph is supposed to sort of represent how many people I would guesstimate are in each category. So one end of the spectrum, you have people keeping secrets in code. Yes, this still happens. Then some people put those in config files or environment variables. At the low point, you have people who are like, oh, I'll put them in a storage bucket. And it's like, well, if you're already putting everything somewhere central, why don't you actually get some additional functionality out of it? And so you see what's happening over here, which is centralized secret management with deployment managers or secret objects like env key or Kubernetes secrets, and secret management tools like HashiCorp Vault, Azure Key Vault, Confidant, KeyWiz, etc. The real important message here is that people are shifting from the left to the right. They're seeing that they have secrets in code and decentralized, that it's hard to manage, it's hard to keep versions consistent across multiple places, and they're choosing to centralize everything. There's really no point at this time to keep things decentralized. And you're like, wait, people are still keeping secrets in code? It's like, yes, they are. Please stop doing this. There was a talk yesterday on private keys in Android apps, and it was really good. You should go watch it. I think he scanned 1.8 million apps and found 6,000 private keys. Please don't put your secrets in code. So what have we learned in terms of what not to do? Putting secrets in code, hopefully if I just say it another 10 times, you'll take that message away. Not rotating secrets. So Evan will get a bit more into this, but this is a trend that we're seeing in the industry right now where it's actually fairly simple for you to change your secrets regularly, so you should be doing it. Not backing them up. They're important. It's great that they're super secure, but if you lose them, you're probably screwed. And not having a strong concept of identity. So you need something that can actually authenticate that can be authenticated and authorized to access those secrets. The last one here is about differential protection. If you protect your secrets the same way you protect everything else in your infrastructure, what's the point of them being secrets? You're not actually using your resources to the best of your ability and doing like proper risk management.
Cool. So these are, I think, when you look at most of the really high-end secrets management and popular secrets management tools out here, these are the properties that are kind of emerging as the most important ones. The two that I care a lot about, one is identity. I've seen people try to create a secrets management tool without a concept of identity of all of their infrastructure, services, and hosts, and it just does not work. I've watched it happen, and it just was a bad tool, and it didn't work, and it wasn't secure. So you really need the concept of identity, and that's really the foundation of authentication and authorization. And auditing, you have to know when secrets change, when they were created, who created them, who fetched them last, and all sorts of different just data points about your secrets to respond to incidents, and understanding the blast radius of issues that arise.
Yeah, and to talk about the other three properties here, encryption, ideally you're encrypting all of your data, but probably you want to be encrypting your secrets at the application layer if you're worried about exfiltration, right? If somebody can get in and your data is encrypted at a lower layer, but they can still get to those secrets in plain text, that doesn't really protect those secrets. The second one here, rotation, I talked about really briefly. So you probably want two different things here. You want the ability to rotate things on a regular basis as part of like a general best practice. I want to change my secrets once a month or whatever it happens to be. And then this is the one that people don't test, which is suppose everything's been compromised. I need to be able to quickly go change all of the secrets in my infrastructure. And that's the kind of thing you want to be doing as part of like an annual testing exercise, but that's actually pretty hard to do right now in most environments. And the last one here, isolation. One part is kind of the concept of separation of duties, right? The people who are managing the secrets shouldn't be the same people who are using the secrets. And similarly, where you're storing the secrets is probably, hopefully, not where you're using them. That goes back to the idea of centralizing all your secrets somewhere, making it easier for them to manage, but also meaning that if one application is compromised, it's not making all of your applications compromised. So what are we looking for? Well, it really depends on the environment that you're in. And since we're at BSidesSF and we're super, super cool, you're either in containers or you're in the cloud, right? Like that's normal, right? Who's on some public cloud in some fashion? Yeah, okay, like 40% of the room. And who's in containers? Maybe 30%?
The same group.
Same group. Who got told they're going to use containers soon? That's usually, that's most of the conversations I have now. People are like, my manager's manager told me that I have to use Kubernetes, and I'm scared for my
Just
security.
lift and shift, it'll go fine.
We should talk. But so you're probably looking at a couple different things. If you're not in the cloud and not in containers, having a standalone secret management solution that is independent of all those things is great. Or if you're in multiple clouds or in multiple environments, you want something that can be completely platform agnostic. We'll talk a bit about the tool HashiCorp Vault that fits that category pretty well. If you're running in a particular cloud very heavily, that cloud provider probably provides a pretty good solution. And if you're running mostly in containers, then you probably want to go with that specific container orchestrator solution. Now, if you're running in the cloud and in containers, because San Francisco, then you have a lot of choice. You can kind of do whatever you want, and it's more about usability at that point in time. So let's talk about this whole standalone secret management thing. And the first tool here is Vault. So what is Vault and how does it work? Vault is a pretty popular open source secret management solution by a company called HashiCorp. There's an open source version that you can run wherever you like. It requires some manual management. You have lots of options and flexibility. You can dynamically generate secrets, such as like database credentials and passwords and things like that, and authenticate in a bunch of different ways. So how does it practically work? Well, you have a storage configuration, which is where, first, you're running Vault probably in a VM or in a container. Okay. You have a storage configuration which stores your secrets at rest encrypted in storage somewhere. You have a seal configuration, which is how you manage the unseal keys for Vault. At this point in time, you're like, what are unseal keys? Vault does this thing that when you spin it up, it's sealed. For you to unseal it so that you can actually access the secrets, there's a Shamir secret sharing scheme to get back a plain text version of Vault. No comment? No? Okay. Next, an authentication method. So going back to what Evan was saying earlier with a strong notion of identity, you need to present some identity to Vault for it to know who you are. You can present lots of different identities based on what environment you're running in. And an audit device. So you're writing all of your logs to something, like our syslog or storage or whatever it happens to be. And then you're generating secrets. So Vault lets you dynamically generate secrets using secrets engines like AWS IAM credentials, database passwords. It also has a couple other useful secrets engines. One is KV for key value, just stores a very basic secret. It has a PKI backend, a secrets engine, and it has a transit secrets engine, which basically encrypts data inline. So you're like, this is great. I have storage, seal, configuration, auth method, audit device. They're all just backends. Just think about them as backends. You have lots of pluggability here, and you can make it work for any environment you want to make it work in. So again, some examples here for if you're running in the cloud. You have storage configurations. See what I did there? For Google Cloud Spanner, which is brand new, S3, Azure, et cetera. If for your auth methods, you have Google IAM, Google GCE, which is the VM system, AWS IAM and EC2. Azure just released a VM1 as of, I think, last week in Vault 0.10. And Kubernetes, you can actually authenticate to Vault directly using your Kubernetes service accounts. And in terms of dynamic secrets, like I mentioned already, key value pairs, transit PKI are probably the most popular options. You can also dynamically generate IAM credentials for AWS, and as of last week in Vault 0.10 for GCP. Cool. So when is Vault for you? You're already using Vault, and you want to use it in the cloud now. That's a really good reason to keep using Vault. You're using multiple clouds. That's another very strong reason, because you can authenticate to it in multiple ways and actually be running it on multiple clouds at the same time if you need to. And you have some dedicated engineers. So we didn't get into it that much, but the unseal thing, keeping Vault up and running can be kind of complicated. So you probably need to have an eng team somewhere who's going to respond to that if Vault goes down.
Yeah, Vault is very heavyweight, and if you don't have engineers, it's and your secrets management solution goes down and your services can't boot, or your hosts no longer can fetch their secrets, it's like it is an operational burden that you have to be ready for.
So what's next? Clouds.
So I'm going to talk about AWS. I've kind of gone all in on the AWS secrets management game, and there's a ton of different ways you can do it. There's actually, they have a lot of different services, and just in the last 2 weeks, they launched a secrets manager service. and that's pretty neat. It's kind of a low cost. If you have thousands of secrets like me, it's certainly not free. It'd be a couple $100 a month, which is not cheap. But yeah, the main services that will help you on your secrets management journey in AWS is KMS, Parameter Store, and then Secrets Manager, depending on like the details of your environment in AWS. So just to hop into it, AWS KMS, Key Management Service. This is a API for doing secure encryption and decryption. It's actually like super bare bones. You can do some crazy stuff though, like delegate keys to other AWS accounts that can be used by them. You can like encrypt, you can decrypt, you can generate data in the form of a data key. You can make AWS handle the customer lifecycle or the key lifecycle by rotating your key every year. So it's pretty neat, and you can have granular. You can use IAM to grant people granular access to a specific key. So the way AWS KMS helps people with their secrets management is they usually use it with another Amazon service like S3 or DynamoDB, and they encrypt their secrets and enforce access control to S3 or DynamoDB using an IAM policy for each service. And then this is like the scheme CredStash if you've ever looked into how CredStash works. And this is actually a really flexible and pretty easy to implement scheme, but you do have to implement it yourself. It's not free. Ssm Parameter Store. This is my favorite, and what we use at Segment. Really, every engineer knows what Parameter Store is, and it's working really well. It's kind of come out onto the scene in the last year, and people really seem to like it. It's kind of like the simplest answer. You have a secret, you want to store it, you want to fetch it, you want to like limit access by service and isolate it per host or service. Parameter Store is really good for this. It's actually really, KMS is simple, Parameter Store is simpler. You can save strings, string lists, and secure strings. That's all you can save in Parameter Store. And it's not specifically for secrets, but it's for config as well, and whatever else your code might need.
What's a secure string versus a string?
Secure string is KMS backed, so they behind the scenes they'll encrypt it with a KMS key for you, so it's encrypted at rest. And this is actually is this actually even visible? Cool. It's not for me. So this is actually the IAM policy that every service. This is the code in Terraform that every service that Segment has. That this is the code for every service that at Segment. This is a mouthful. That actually enforces access control between secrets. That actually enforces like one service can't fetch the secrets of another service. So based on the service name, they get a little like IAM policy that has their secrets name appended to this block of the secret store in Parameter Store, and every single service and host get that at Segment, and it works really well. This is actually what it looks like. We've built this command line tool called Chamber, which will put secrets, fetch secrets, and exec programs after fetching secrets for the program. This is an example of me listing all of our secrets in the Gateway API on stage. And so the Gateway API is the only service at Segment that can fetch these secrets, except for me. I can also fetch them. So it's pretty neat. It tells you the version of the secret. So if you change this, if you rotate the secret or create a new one or whatever you do to it, it'll tell you who did it, what time, and what version you're on. You can also roll back or fetch specific versions. So you can say, okay, I want version 2 instead of version 3, and that's pretty neat. I think this slide is really impactful into why nobody's heard of Parameter Store, because it's way down here in the bottom left of the EC2 console. Like, good luck finding it if you didn't know it was there. you're just not going to find it. But it's super useful. It's the most useful AWS service that nobody's heard of, in my opinion. So this is kind of like the playbook if you're trying to build secrets management all on AWS. If you have a significant amount of infrastructure that's not on AWS and you need this super flexible and secrets management setup, use Vault. If you just have a simple setup where you just want to have secrets and fetch secrets, then use Parameter Store. If you have ridiculously high load requirements, don't use Parameter Store. We've had issues where we try to boot up thousands of services that all call a parameter store at once, and they get unhappy with us and rate limit us. Then our services don't boot healthily, and that's bad. So you'll want to build something with KMS and S3 or DynamoDB. And then finally, if you really have rotation requirements and you're not worried about the cost, Secrets Manager is probably a good option for you.
Cool. And on GCP, we also have Cloud KMS, which is our cloud key management service. And very similar idea, you could encrypt secrets with Cloud KMS and then store them in GCS, which is our storage service. Use IAM and cloud auto logging to track access to that. The recommendation there is actually to turn on cloud auto logging's data access logs, so you would actually log every single time that secret is read. There is fairly detailed instructions on how to do that at this link, but it's not automated, so there's no kind of parameter store equivalent or secrets manager equivalent on GCP.
Yet.
So if you're running on GCP, what should you do? If you just need your secrets to be relatively secure and encrypted, bonus is that Google Cloud Platform encrypts all your data at rest anyways. So you could just keep it in Spanner. That's a pretty popular option. If you want to further encrypt things at the application layer, follow the instructions from the previous slide and store them in either Spanner or GCS. And if you have more complex requirements or you're running on GCP and other clouds, then probably HashiCorp Vault is going to be a pretty good choice. So the last area here, which is you're running in containers or you're running in containers and on the cloud. So some of you might be familiar with Docker Swarm. Docker Swarm has so first, for people who do not know what containers are, you have worker nodes that are going to run jobs, and you have swarm managers that are going to tell the worker nodes what jobs to run, and that's the basics of container orchestration. And the swarm managers keep a state, including secrets, in a distributed RAF store, and that's how they keep track of what's going on. Docker has secrets as a concept built in. So, and you're like, wait a second, I use Docker. I've never seen Docker secrets before. They're not as part of the container, they're part of the service. So you have to be using Docker Swarm, not just Docker. And they're stored in the internal distributed state store. The bonus is that they're already encrypted at rest. That's great, you don't have to do anything else. And there's mutual TLS between the swarm manager and the workers, so your secrets are distributed securely all the way to your worker, which is really nice. It's actually pretty straightforward and simple on Docker Swarm. And we really wanted to talk about Docker just to show this really cute photo. That's all, okay.
I love that crab.
So what happens on Kubernetes? Kubernetes, similar idea to Docker. I have nodes that have pods that have containers, and I have masters that tell the containers on all of these pods what to do, and I store my secrets in etcd. The only reason I want to call out pods specifically here is unlike in Docker, where I believe the secrets are scoped to the nodes, in Kubernetes, secrets are scoped to the pods. So that's a difference worth calling out. So secrets originally in Kubernetes were not encrypted at rest. As of 1.7, they are. So you can have secrets encrypted in etcd at the application layer using AES CBC, AES GCM, or secret box modes. And you're like, that's great, but I have a central secret management solution and I don't want to deal with this. No problem. In Kubernetes 1.10, you have an external KMS key that you can use to encrypt the secrets that you store in etcd. There are plugins already available for Azure Key Vault and Google Cloud KMS. Those are not in Kubernetes core, so if you're looking for those and not finding them, you have to go to the Microsoft and Google GitHubs separately. And I know that the community is also working on developing one for HashiCorp Vault. Cool.
I also think it's worth noting, like the architecture of the Swarm versus the Kubernetes, like the slides were almost exactly the same, except the name Docker Swarm was replaced with Kubernetes, it looked like to me.
What are you saying?
And I think that's really telling that container orchestrating frameworks and like cloud platform as a service are really going towards providing this as a first-class service and first-class feature of like using Docker Swarm or using Kubernetes. And I think people really see that as like a really important feature and a differentiator. And I think like this whole ecosystem will get simpler as you further embrace the cloud.
I agree. So what do we talk about today? We talked about a whole bunch of different secret management options, which include HashiCorp Vault, AWS Parameter Store, Secrets Manager, GCP Cloud KMS, Docker Swarm, and Kubernetes. And we talked about some of the requirements that we have around those: identity auditing, encryption. Sorry, it's hard to read. Rotation and isolation.
I don't remember what I'm supposed to say here, so I think Maya's covered it. Oh, that's what we've talked about. She's right.
all the solutions that we talked about had some sort of notion of identity auditing and isolation. So if you have a specific requirement around encryption or rotation, look for that specifically. Not everything is doing that as easily.
That's brand new.
Yeah, rotation in particular, I think, is becoming very trendy. The second point here is that basically every solution does a pretty good job and exists in every environment. So you're probably going to pick something based on the environment that you're in, which is why we talked about containers and cloud specifically, and on usability. So do not just listen to us, but go read some blogs about how easy or hard it is to use these things.
Yeah, usability is key because if you actually want engineers to use it, it better be usable. And so like coming down and from the security ivory tower and saying like, this is the secrets management solution we use, like get with the program, never effective in moving security forward.
So what didn't we cover? What's not currently covered in terms of secret management? One is usability, which is called out. Two is a root secret. So I mentioned earlier, for example, HashiCorp Vault has this unseal where you do a 3 out of 5 Shamir secret sharing scheme. I mean, like in a KMS, there's a root key somewhere that's managed by the cloud provider. And in Kubernetes, if you're just encrypting at the application layer, that root key still has to be stored somewhere. It's stored in its CD as well, unless you're using the external KMS. So that is still potentially an unsolved problem. At the end of the day, it's turtles all the way down. So how do you protect that first secret?
Nah, yeah, and this is a good overview of like 2018 secrets management, and I hope 2019 secrets management. It's like rotations bigger and more important, and better features around it. Like Secrets Manager just came out, and that specifically is supposed to support rotation. And besides that, just more usability. I think that'll really help. Just better tooling around this whole problem.
So what do we learn today?
Just encrypt. It's that easy.
Don't put them in code. That's bad.
Yeah.
Great.
Does anybody have questions? They're shaking their head no at me because I don't have time, but feel free to find me or Maya.
All right. Thank you so much.